Okay, so for loop, we know now now it's a definite loop. Let's talk about its syntax. The header of the loop is in the form of for, and the variable name is called the iteration variable in the name of container or iterator, and don't forget the semicolon, the colon, then the code block or the body, whatever it is, indented one indentation until finished indented. So again, the syntax is for iteration variable in container or iterator semicolon, and then the body. The body of the loop, the same for the branch, can be either the keyword bus if no operation or something is not yet ready, for example, a function that is not yet implemented, one statement only on the same line, or a code block containing one or more statements, and all of them share the same indentation. And as we know now, code block can contain another loop or another branch. And the code block, the new code block will be either the other branch or loop has a body, but it can be either what or what or what, you know. Okay, so this is something that can go from one level to the second, the third, the fourth, up to the end of the computer capacity. So we have two forms of for loop: iterating over collection, iterating over range. We'll start with iterating over collection. Collections here. Those collections here will refer to sequences. So a sequence can be something like a week containing weekdays from Monday to Sunday. This needs to be updated, to be collected. So yeah, fine. So from you will be clever if you notice what I corrected. From Monday to Sunday, weekdays, and iterating over the loop. So we say for variable name, here day, in week. Week is a collection, day is a variable name, and we do whatever we want. Simply can print the day. And as long as the body in this simple example is one statement, we can write it on the same line. For day in week, column, print day. But this format is not preferred. It is correct, but not preferred. In this example, week is iterable, containing all possible values. Day is iteration variable, which will get. Sorry, I had an urgent call. So we said that week is the iterable, contains all possible values, and day is iteration variables that visits all the values in the iterable, and print day is loop body, which is executed once for each value in the sequence. So whether the loop body is one line or several lines, the effect is the same. Let's try that in the IDE. So week is Monday to Sunday, for day and week, print day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. If we enable the next line, next code, which is the same thing, but on the same line, let's add print and play, run. Monday to Sunday, Monday to Sunday. Okay, so both cases, the effect is the same. Iteration variable, iterable or container, and body. Okay, let's do some work now. Another example on what to do in a body, in a loop body. We have a list of friends: Alice, Bob, Mark, Amr, and Joe, and Joel. Um, we need to count how much we can borrow from the friends for up to make a project. So the total number is the total amount I counted so far is 0. Looping over all of the friends. So we say for friend in friends, and the variable is friend. Uh, Print hello, and here friend is the name. It will base with the name Alice or Bob or Mark or Amr or Joel, whatever. Hi, Alice, how are you? Then we input how much can you lend me? We ask uh, your friend how much can they lend you, and bus number into a float, the string into a float, and the float is set in a variable called amount. Then the total is updated by adding that amount. So no total plus equals amount. This is another way of writing total equals total plus amount. We know that already. So after every iteration, the total will be increased from 0 to value, then first value, then second value, then third value, then fourth value, then fifth value, by adding the amount every time until we reach up to the total. So this is the body containing these 3 lines, and outside the body, we indent back saying that we finished already the body and we are now outside of the loop. I can borrow total of this number value. Let's start the project. Okay, let's try that. Run. Hello, Alice, how are you? How much can you lend me? Answer is 0. Hello, Bob, how much can you lend me? Say 100. Mark, let's say 150.5. Amr, let's say 100. Joel, let's say 1000. Wow, I can borrow now 1350.5. Let's start a project. So 0 plus 100, 150, 250.5, 350.5, 1750.5. This is the total amount now. Okay. So this account, this is the accumulator. This is the loop head here, loop body. In the loop body, we use the variable. We print the name here, and we add some value to the accumulator and use the accumulator outside. Okay. Now, instead of summing the values of values, let's do something more complex. Let's find the average, not only the sum of numbers that divide 3. So here are some list of values, whatever they are. I don't want all of them. I want only those which are components of 3 and can be divided by 3, can divide 3 without um, can be divided by 3 without a reminder. So I have a total as previously, and I also keep track of the count of those which are within the condition I check. So for value and values, if value um, modulus 3 is 0, which means if they are multiple of 3, total plus equals value, that's previous time, and the count plus equals 1. So the count will be increased only with values that are multiples of 3. And outside the loop, here in the back, the average of the values that are multiples of 3 is total divided by count, is the average. Because time we want total, now we want count. So what we did here, we did 3 things. Filtering multiple 3. We can filter in or filter out. Now we're filtering in. This is done here in the if condition, in summation, counting, and finally averaging. So in these 5 or 6 lines, we did these steps: filtering in, summation, counting, and averaging. Averaging is by dividing the total over the count. Maybe it's better to name this. Uh, Fine. Okay. Let's try that. That it doesn't. Doesn't run. Okay. The average of multiples of 3 is 20. How did this 20 come from? 2 is not a multiple of 3. 10 is not. 15 is. So we have 15. We have 33. 5 is not. 12 is. 12 plus 33 plus 15. 12 plus 33 is 45 plus 15 is 60. 60 divided by 3 is 20. You can trace it if you want later. No. And the core of this lecture. Okay. So up to now we were checking count values one by one and keeping result. Now let's find a value and keep going with it until the end. So we want to find the maximum value of all values, the same values here. So we want the maximum value when we wanted to sum or get the average. We started with a variable that is the total, another variable also for the count. Here was the total. The total was 0, so that when we start, it gets added to something that is not there. We also need here to start with something that is that cannot be a maximum. So we start with the negative infinity because it's the smaller possible number that these or any other values can exceed. So there is no possibility that negative infinity can be higher than anything. I tell you why now. Very soon. Starting with a variable called max, with the value uh, negative of mass dot infinity. Remember that we are using the module mass, so we need to, in the file, we need to import mass, but not our point here now. And then we iterate over values, value and values. Now we have max starting with a very minimum value. We want to get the maximum value, we start with the minimum value. We want to sum, we start with 0. We want the minimum, we start with maximum, and vice versa. So now we have maximum containing the minimum possible value that Python can hold, which is minus infinity. So if for every value, we compare every value with the current max we know. If the current value is greater than max, we update the max with the current value. So if value greater than max, max equals value. So of course, obvious that the first round will be updated, first iteration, second, and then it may or may not be updated every time. And at the end, after the loop, we output the maximum value after updates. The first iteration, 2 is definitely greater than minus infinity. Second iteration, 10 is greater than 2. So we keep max as 10, maximum so far. 15 is greater than 10. So the maximum so far is 15. 33 is a big number, but actually, unfortunately, it's negative number. So it's actually small value. So the maximum is 15. 5 is the next maximum value. Is check the next. It's not greater than 15. 12 is check the next minus 12. So it's smaller than 15, so I don't update it. So the last maximum value will stay at the value of 15. Maybe you can add some lines to make it let's try that. That's the code. Maybe we can add here. And updating to no. Okay. We can add more lines of code here, but not in the presentation. Presentation is limited to small screen size. Okay, so we started with 2 minus negative infinity, updated to 2, updated to 10, updated to 15, not updated anymore. So the maximum value is 15. We found the maximum. Now finding the minimum will be your assignment. It should be similar idea, but you want the maximum starting. You start with very low value. If you want the minimum, you need to start with very high value. I won't say what it is. You figure it out yourself. And when you compare the new value is instead of greater than max, it should be less than max. You are intelligent enough to get the answer yourself. Okay, next. How to control how to control the behavior of the for loop, or loop in general. There are two important keywords: break and continue. They control the behavior of the final control the behavior of a loop. We have continue and we have break. Continue skips the remainder of the current iteration only, while break skips the remainder of the current iteration and all future iterations. So in other words, it exits the loop altogether. Exits the loop altogether. Again, we have continue and break. They are similar in function, but they are not the same. Definitely not the same. Continue skips the remainder of the current iteration and skips the next iteration. Break skips the remainder of the current iteration and everything and exits the loop altogether. When do we need that? And with this and we need that. So example of the first one is while searching for prime numbers. If you want to search prime numbers, you how do you know that a number is prime or not? By trying to divide it by all numbers below it. Actually, not all numbers until only its square root. And if we find that any number before it is a divider, then it is not uh, a prime number. We should not waste more time in checking any other numbers. Let's give an example. Now, if I know that if I'm checking 33, let's say 55. 55 cannot be divided by 2, can't be divided by 3, cannot be divided by 4, can be divided by 5. So it is not prime. Do I need to continue dividing by trying to divide by 6, 7, 8, whatever? I don't need to. So I simply skip the rest of this iteration and try now the next number, which would be this is 55, try 56, divisible by 6, 57, 58, etc. Okay, so I simply skip checking the rest of the denominators and move on to next number. I will give examples in over these two keywords just next slide. While break, I exit the whole loop altogether. Examples can be simple, like if you have a two players game, if one player wins the match, something like connect four. Connect four, if one of the players connected four, then there's no use of completing even the current iteration or the whole loop, the whole match. Where I simply exit the match and declare the winner. Another example, if a user inputs end, if I'm asking him to do several inputs and then he write end, I think is the problem. Or if I'm doing a statistical calculation and I drawing samples until I have taken enough samples, I just ignore the rest and break the whole loop. Let's see some examples of break and continue. Before we see that, it's nice to know that usually both break and continue are present in the body of an if statement. Otherwise, how you know that you need to break, you need to edit, or you need to continue, unless there is a condition and you check that condition. Okay, examples of continue. The first example, we have a list of students and their marks. Some of them have passed, Some of them have failed, but some marks are not yet available. Maybe they didn't pay the fees, or maybe they didn't have the exam yet. So the marks are not available, indicated by none. We have a list of tuples. Every tuple contains two items, a name and the grade. The grade can be passed, failed, or none. In a list called student result. Okay, we iterate over the results to print on the available values. If student result for student result, in student results, this is the iterator variable, and this is the whole container. So we have the iteration variable, call it student result. It's itself tuple. We can get the first item and second item in the tuple using indexing. Student result of 1, 0, and student result of 1. Later, when you study indexing, so you study tuples, you know that is an even more efficient way of writing it, but it's not our case now. So now I get extract name and the result from this item or this item or whatever. I want to skip the iteration when the result is none, indicating that it's not yet available. So if result is none, continue. Okay, if it's not none, I should continue. What is there in the loop body? I print name colon result. Let's test that. We have Alice post, Bob not available, Charlie failed, Amra passed. So you will print only 3 results out of 4. This is what will happen. Number of continue. Yes, Alice passed, Charlie failed, Amra passed, but Bob is not printed. It's just skipped out because of the continue keyword. Okay, next example. And in this example, we'll see that, actually, both examples, we see that continue can be used also to filter values to process. If you want to print the odd numbers of list, here is a list of values for integer I in the list of values 20, 45, whatever. If I modulus 2 equals 0, means if it's an even number, continue. So what will remain after this line? It will be the odd numbers. Okay, I will print it. So I used the word continue to filter out the values which I don't want, to keep only the values which I want. This is a direct use of the keyword continue. Let's try that. Okay, what before we try it? Let's try that. We have 20, 45, 12, 45 is odd, 37 is odd, 33 is odd, so only 20, 12, and 44 should be printed. So that, yes, 45, 3.7, 307, sorry, and that's 3. Uh, Before we discuss, I want to show you how we test something. I want to trace it to run it step by step. Just for your interest. And now I is in the first value, it's 200. Step over. This condition is true, so it continues. What will happen? It will jump back to the next iteration. 45 is the next value. Now I took the value of 45. Is it even value? No. So it will not evaluate the body. Continue, and with the body of the f, and will continue in the body of the loop. Now print I. Will have printed I. Yes, 45. Okay, and so on. Now continue the same. Now 45. So okay, let's go to the next slide. Now we have seen let's see break. Here I'm writing an implementation of the function called is prime. The function takes a number and checks whether it's prime or not. A variable is prime, a number is prime. This is interesting definition. We don't have yet in our mathematics a formula to define prime numbers. So we know a variable, a value is prime only because we cannot prove it is not prime. Again, all numbers are prime by default until proving otherwise. So this is the case in our mathematics till the moment, until if someone managed to find the prime number formula, he will get $1 million. This is real. So we start by assuming that any number is prime until proving otherwise. Okay, how could a number be proved otherwise? We have 3 or 4 checks. First check, if number is 2, 2 is a special case because it's the only even prime number. All other prime numbers are odd. So if the number is 2, when we set is prime is true. But actually, is prime is true already. So we don't need this operation, this instruction. We can just pass. Now is an example of the keyword pass. Again, because is prime equals true is this already the same here. So we don't need to write this instruction. We just pass. We'll be consuming memory and processing time. Okay. So if the number is 2, we don't do anything. We assume it is prime. It is prime. Else. Now, else if number is smaller than 2, meaning 0 or 1. Or number is divisible by 2, meaning it's an even number other than 2 already because we are in the else of the first if. So what goes here is when the number is either 0 or 1 or odd. If it's 0 or even, sorry, 0, 1, or even, then S prime becomes false. Other than that, we maybe write. I need to rewrite this. This is more informative. 0 or more, or even number higher than 2. In this case, S prime becomes false. Else, and here is the big part. We start a loop to check the divisibility of this number by all the numbers from 3 up to the square root of this number. I know we didn't study range yet, but it will come in the next few slides. Anyway, so you can return to it back to see that this line means for the divisor in the range of from 3 to the square root. Number power half is the square root of the number. What will you do? Check its divisibility. If number divisible by divisor, then S prime is false. We know now it's not prime. We found the divisor, and we break this loop. We don't need to check. If I know that I have 10 million, 10 million is divisible by 5. I don't need to continue checking. I don't need to continue checking until 100 or 100, 1000. Just break. This is not prime. This is enough. Enough is enough. I don't need to continue in whole loop here. Okay. Then out of this if elif else construct, I will have the value is prime available, whether it's either true from the beginning or unchanged or false in one of these two cases. In all of these cases, I will have the final value. I just return. So the bottom line here, what I did in this function, why I'm presenting it, bus is useful when you don't need to do to write anything. Okay, and break is your secret weapon when you don't want to continue the loop altogether. Just exit the whole loop. Okay, that was about pause and break. This is the end of the first part of the for loop, which is loops that no, before we go that, let's test it. Test it on the yeah ID. Example of break. This is the function is prime. Number equals 0 equals 2 plus this if number less than 2 or even. Otherwise, check divisibility by everything from 3 down to up to its square root. I want to put breakpoint here and test that. Try that. So this is the function. I I wrote some small check code to check some values 11, 45, 12, blah, blah, blah. Let's see what it is. Trace it. In the previous case, when we hit continue, we went out to the head of the next iteration. This time, if we hit break, sorry, break, yes, we should get out of the loop and go to the next iteration out of everything. Okay. Divisor now. Divisor now equals 3, and the number is equals 11. This was false. So in the next iteration, nothing, no more iterations. So we know that 11 is prime. Okay. Next. Now 45. We know that 45 is a multiple of 3. Let's see what will happen. We know that 45 is so we hit this if condition body. So we'll set is prime to false and the break. Now when we execute break, we will not only get to the next items of for loop, but we'll get out of the loop. Yes, we got out of the loop. Let's try the next one. 12. 12 is not prime as well. What happened? Oh, yeah, we know that we finished the already 12 already. Okay, now in 307, we try to divide it by 3. It doesn't accept. It's divided by 7. Didn't accept. Didn't accept. Divided by 9. Didn't accept. 11. Didn't accept. 13. 15. 17. We hit it, and we know that now we will print that it is prime. Okay, and so on. Let's take this off. continue. Okay, so this is the set of all values. And we can go to now to the next video, next part, counting arrange. So we looped over collection. Now let's count arrange.